Very top of the day to you, Dr. Aslan. It's good afternoon here from Nigeria. Stella Adejumo is my name, and these are my details on the screen. All right. Okay, I want to say a very big thank you for the opportunity to present on regression analysis. I will start this video by saying what regression analysis is. It's a technique that is used to establish a relationship between variables. Okay, one being the dependent variable, which is often represented by y, and the other the independent variable represented by x. Okay, this linear regression is used to predict relationship. Is used to predict relationship between variables. Like I said, you predict the value of the dependent variable and used to explain the changes of impact of an independent variable. Okay, there are two types of linear regression. We have the simple linear regression and we have the multiple linear regression. Okay, simple linear regression deals with one dependent variable y and one independent variable x. Okay, so oftentimes in simple linear regression, what we have is one single slope. But when we talk about multiple linear regression has to do with one dependent variable and two or more. It has to be two or more independent variables represented by x1, s2, or sn, depending on the value of the independent variable, the s. So we have a two or more slope when it comes to multiple linear regression. Now I have a task before me this afternoon, and I'll quickly take you through the task. So I'm going to be moving to Excel to explain the task to you. This is what Dr. asks us to do, an assignment. Solve this problem. We have been given this data value. So the first task is to predict C based on the data set A. What will you predict when an independent value of A is 33? So these are the value here. I've already moved them to Excel. We have the ABC. So to solve this A part of the question, I'm going to be, okay, we are looking at A and we are looking at C. So I'm going to be copying out my A and C. Okay, this is my A. Alright, and this is my C. So to predict, okay, to predict the value of C when A is 33, the first thing to do here is to calculate the slope. Okay, Excel enables us to use certain function to calculate that. So I'm going to type slope to calculate my slope. I'm going to type slope. So I'm going to be using this formula equals slope include my parentheses. I'm going to highlight the value of the known variable, which is my y, from C. I'm going to highlight this, separate it with a comma, then highlight the x value. Alright, then close up my parentheses and press enter. So this is the value of my slope. Now the second thing I'm going to be doing is to calculate my y-intercept. So I'm going to be using the same procedure. Okay, equals intercepts. Okay, my parentheses, I'm going to be highlighting the same value versus C with a comma, then A with a comma, then close up my parentheses, enter. So this is the value of my intercept, and this is the value of my slope. So I can, based on these two values, I can write out my predicted equation to be predicted equation to be equal to intercept plus slope s. So with slope x, okay. So if I substitute the values, my predicted equation will be predicted equation. I can shorten it with PE. Let's just say PE. Oh, sorry. PE equals the intercept value is 32.08 plus the slope plus 0.55x. So that is the predicted equation. So the next thing I'm going to be doing is I want to predict C when that set A is 33. So I'm going to be using this formula. Let me use stay here. So for A equals 33, to predict C, I'm going to be using this formula, below. Okay, so we have it's going to be given as C equals intercept. So intercept plus slope multiplied by the value of A. So I'm going to be using this formula to predict the value of C. So C will be equal to, the value of our intercept, don't forget, is 32.8. I'm going to be substituting that 32.8 plus my slope 0.55 then times A. The given value of A is 33 times 33. So adding up, and first of all multiplying, so 32.08, this value is going to give me 18.16. 18.16. I guess, okay, like 18.15 based on my calculation. So adding up the two will give me 50.23. 50.23. That is the value of C. C is predicted to be 50.23 when the data set of A is 33. Alright, when the data set of A is 33. Now I'm going to be solving the B part of the question. Sorry, I have a little bit of discussion here. So I'm going to be solving the B part. B part says predict C based on the data set A and B. What will you predict when the independent value of A and B are 22 and 44 respectively? Now, like I told you earlier, I have my values here. I'm going to be copying it here and using the I'm going to stroll up, copy. So I'm going to stroll up to have more space for the B part. Okay, this is the value here. Let me paste it here for proper repositioning. Right, it's better here. Prefer it here. Okay, so in calculating this, there are different type of method. So I'm going to be using this simple method to calculate this value. But looking at this question keenly, you will agree with me that this is more of multiple linear regression as compared to the A part, which is simple linear regression. So what I'm going to be doing basically this afternoon is to go to my tab. I'll click on data. Under data, I'm going to be choosing data analysis. Under data analysis, I'm going to be choosing regression. This is regression here. Then I'm going to click OK. So here is my table. So I'm going to select the value of Y, which is C, represented as C here. Don't forget, I'm going to be including a C. I'm going to be selecting the range, okay? Yes, that's my Y value. That's the C value. Then for X range, I'm going to be selecting A and B. Like I told you, we are looking at multiple linear regression, so we are going to be selecting A and B. So that's the value of A and B. Okay, then I'll come here, check my label, then my output range where I want it to display. Okay, I can choose here, can display here, it's okay. So sorry, oh sorry, it's changing the A part, I didn't move it. Okay, so I'm going to be coming here, so the output range will be here. Let me shift this so it will be here. Alright, so I'll click OK. Okay, so this is what let me move here. Sorry, let me move here. So this is what I got. Let me try to expand the cell for visibility purposes. So this is what I got using my data analysis tool. Okay, this is what I got. So these are the coefficient value. For the intercept, I have 41.83. For slope 1, like I told you, for multiple linear regression, we have more than one slope. Slope 1, I have this. Slope 2, I have this. So I'm going to be using my formula to calculate the value. I'm going to be using this formula. I'm going to be C, to calculate C will be equal to intercept, my intercept, plus the value of slope 1, then times my A value, the given A value. Don't forget we're given 22 and 44 respectively. I'm beginning at A value, then plus slope 2 times my B value, which is will be 44, my B value. Alright, so I'm going to be substituting all my the values here. Like I told you, C is going to be equal to the intercept value here is 41.83 plus the first slope is 0.455 times 22, then plus, then the second slope is a negative value, don't forget. So I'm going to be putting minus 0.187. Oh, sorry. Sorry, I have a little bit of distraction here. 0.187. Then I'm going to be multiplying it by the value of B, which is 44. Alright, 44. So now these are the my values. So to solve this, I'm going to be having C equal 41.83 plus 0.455 times 22 will give me 10.01. Then when we have plus and negative, it will give me negative. So I have negative, when I multiply this, it's give me 8.228. So expanding further, I'm going to have C equals, that would be 51.84, 1.84 minus 8.228. So the value of C will give me 43.612. Approximately, it can be written as C equals 43.6. So C is equals 43.6. So based on